So yeah, you're going to be putting little blotches of color into this canvas. Here you go. So here we've put a blotch on 13 and a blotch on 17. Okay, what's the first thing that you notice whenever you do that? What do you notice? What do you think some of the rules are for this puzzle? Again, I'm not going to tell you all the rules. I'm just going to show you. That's what a blotch looks like on 13, and that's what a blotch looks like on 17. Well, let's see. How many squares are there in this 13 orange blotch? How many would you guess without even counting? And it's 13, yeah. Yeah, we've got 17 over here, and 17 blue and 13 orange. So that's right. The size of a blotch has to be equal to the color that is highlighted inside that blotch. That's right. Okay, so that's not all the rules, but yeah, let me show you another rule. So another rule is that around the central blotched color, it has to be surrounded by that color. So this orange 13, it has to be surrounded on all of its sides, including diagonals, with the orange. Okay, so 23 over here, that looks fine because it's totally surrounded, and 13 also looks fine, it's totally surrounded. You're trying to fill up the whole canvas. Yeah, so Herndon and Willis, you're trying to fill up the whole canvas with your colors. Okay, so let's just take a moment and see. What do you guys think? Is this a good solution? Okay. Okay. So Janowski's not sure. This is not a good solution. Brewer and Herndon says no. Hardy says what? Park says okay. Moore says Okay, so let's just look at why this is not a good solution. First of all, did you cover the whole canvas? Yes or no? Well, you managed to cover this part here with purple, this part here with red, and this part here with green. But you left two parts that weren't covered. So that's kind of like drawing the Mona Lisa and forgetting to do an ear, right? You don't do that. You cover the whole canvas whenever you're painting. Next, you have to think that there's another problem with this. Yeah, there's a problem with green. What is the problem with green? Whitaker, what's the problem with green? So remember, this 19 that's highlighted, there's going to be 19 squares in green. First of all, can you please check that that is true? Otherwise, we've got a problem. Have we got 19 green squares? 1, 2, 3, 4, 5, 6. Think we're okay. But Steele is correct. It is not surrounded. You can see that there is a problem with this 19. 19 has to be surrounded on all of its sides, and this 19 is not. You can see that the 14 up here should be green, but it's not. It's red. And if we colored that green, then this red wouldn't be surrounded by red. So you can see you've got a problem here. So this is a bad solution. What about this solution? What do you guys think about that? Does that look good? So Heatley, the problem is wrong. Well, the 19 was wrong. So Janowski, you are trying to cover this entire canvas with as many colors as you can. And every color, you put a blotch. So we've got a purple blotch that's centered on 6. You've got a red blotch that's centered on 9. And you've got a green blotch that's centered on 25. So in order for this to be right, all of those around the 25 have to be green, and they are. The 19, the 20, the 26, the 32, and the 31 are all green. thumbs up. All of those around the red have to be red. They are, including diagonals. They are. Thumbs up. All those around the purple have to be purple. 5, 11, and 12 are all purple. We're good. Next. So this is not 25 green. Morris thinks there's a problem. He doesn't like the 25 green. There's not 25 green? I thought there was. 1, 2, 3, 4, 5, 6. That's 12. That's 18, 19, 20, 21. There is only 21, not 25 blotches. There we go. But we can't color that. Yeah, so this is all wrong. Yeah, we can't put the 25 there. So now it's your turn. You guys have to come up with a solution. Go ahead, Ponder. Ponder, you get to choose any number to start with. So for those of you who are still thinking, what's going on here? So Ponder doesn't get it. I'm sure there's other people that don't get it too. So Ponder's going to choose the 6. So Ponder, what color do you want for 6? You can choose any color. Herndon suggests green. Herndon is suggesting that we color everything green. But we are trying to color, let's go like that. We are trying to color with the most colors possible. Okay, so yes, we could color everything if we could color everything the same color, but that's not interesting. Okay, so Ponder, we have to, if we're coloring this one green, we'll do it a nice dark green. Okay, then these ones have to be green, otherwise we've already failed. Okay, but that's only 4 greens, so we need to have 2 others connected. Okay, another 2. So we could do 4 and 10. We could do 4 and 18. We could do 10 and 17. What do you want? 4 and 10? Okay, Whitaker is going to say 4 and 10. There we go. You have got 1 blotch. Congratulations, it is time to celebrate. We've got 1 blotch. Go ahead, choose another blotch. Hardy, you want? Yeah, you could have chosen 17 and 18. So Herndon, you want 10, 17. You could have chosen that. But now we're ready for another blotch. 33 red. So if we choose 33 red, okay, then these ones all have to be red around it. So we can cover that. There we go. And then we have to have 33 squares. Whitaker, no shouting, please. So we'll do 8 later. Okay, right now we're doing 33. How many squares do we have left? I think that's all of them. Okay, how about that? Does that work? So do we have 33 total squares colored red? Is that going to work? How many squares do we have? Oh wait, we only have 30 squares left. Yeah, so this doesn't work. This is a failure. There's only 30 squares left. So yeah, we can't do 33, but we can do 30. So we're going to move over to 30. So this would be a possible solution here, like this. Yeah, absolutely. This would work. Okay, but we're trying to like just color, just drawing, just painting with 2 colors, green and red. You know, it's not that good. We want more colors. So yes, you guys have found a solution. It is an okay solution, but it is a solution that we can still probably do more than just that. Okay, so let's try to get more colors in there, not just 2. Can we get 3 in? Okay, 4 and 18. Can we do 4 and 18? Oh, wait. No, that was for a different answer. Okay, Whitaker wants 8. So we are going to go with Whitaker. Whitaker's 8. And what color do you want? We're going to choose a green for that. So all of these ones must surround it. So all of these ones must be green as well. There we go. So there. Okay, what other color do you want? One red. Well, we'll try the one red later. Whitaker wants to do 11. Okay. So we'll do Whitaker's 11. Okay, all of these ones must be surrounded. There we go. Let's go like that. Okay. There are 9 green, Moore says. Oh, yeah. So we're stuck. We can't have all these green. We've got too much green. So we failed. See that? Yeah, we've got 9 green here, not just 8. Okay, so yeah, we've already crashed and burned here. We don't have enough red, and we've got too much green. Okay, so yeah, that's a failure. Okay, so yeah, I guess there's no way to start with 8. Yeah, so Herndon wants to start with 6. Okay. Okay, so Herndon and Ponder are both fans of number 6. There we go. We surround it. Let's surround it like that. Okay, and number 6 is typical. McLaughlin says 6 is typical. What do you mean 6 is typical? Like it's a good one to start with. The smaller the number, the better. Yeah, to get many numbers in here, that's an interesting point, Heatley. To get as many numbers as possible, you don't want to be starting with like a number 36. Yes, we could start with 36. If you started with 36, we could color that yellow, for example. But then, of course, we're doomed because that's going to be the only color on our entire canvas, right? You can see that is going to be it. We are going to end up with a totally yellow canvas. Who wants that? I'm sorry. That's just no good. So yeah, I like Heatley's idea that we want to try to make the numbers as small as possible. I think that's good. Go with 1 and 2. So Heatley is suggesting to start off with 1 and 2. So we're going to try that. So someone else has to come back and make that. So what colored? Well, we'll make this one here. Let's make it red. Let's make it green, number 1. Okay, and then this has to be surrounded, of course, on all sides with other greens. There we go. Okay. Oh yeah, 1 doesn't work because now we've got 4 greens, of course. So yeah, that doesn't work at all. Okay, 9 was another, Willis's idea is 9. So let's try 9. Okay, here we go. We have to surround all of that. Okay, go ahead. There are 4 green. Let's see, 4 green. Moore, I don't understand there. Oh yeah, there are 4 green for the number 1. Yeah, that's right. Okay, so we still have to make this 6 one work. We've Ponder, you can see that there are only 4 red ones. And Moore, there's only 4 red ones, and we want 6. So solve it, guys. Which ones do we want? Yeah. Do you want to have 17 or 18 or 17 and 23 or 18 and 24? I think those are the only options, 17 and 18. Fair enough. Done. Okay, what next? Herndon, I'm sorry it froze. I think that's only with you, but I'm not sure. Okay, 1 blue. Janowski says 1 blue. So if we do this, Janowski, for 1 blue, then all of the ones around must be blue as well. And you can see that that runs into a problem because all the ones around the number 9 have to be green. So we can't have number 1 and number 9 at the same time. Okay, it was frozen. Okay, Steele. That's interesting. Snell says it wasn't. So it's interesting that it freezes with some of you and not with others. I didn't know that. I thought it would freeze with everybody. Okay, so can we finish this? Can we get another color here, or are we doomed? Can we finish it? Oh no. Yeah, this doesn't look good, guys. This doesn't look good. The number 1. Yeah, but Whitaker, if we do the number 1, you understand we have to do all of the ones around it, right? And if we do all the ones around it, then we don't just have a single 1. You have a 1, 2, 3, 4. You've got 4 colors, right? So that's where the problem comes in. Yeah. Okay, no need to yell, guys. Let's focus on the math. We won't talk about screen freezes anymore. We should try 7. Yeah, because right now the lowest number that we can fill, we can't fill in 24 because then it would surround. We can't blotch on 24 because then it would mess up with these pink ones. So yeah, and so the lowest one we can choose is 25, but there's actually 21 squares here, so we can't do that. So I think I like your idea of starting with number 7. So let's do that. I'm going to erase this here. Okay, let's go like that. And I'm going to make it number 7. It's possible that we can only get 2 numbers in here. That would be sad, but it might be realistic. There we go. Okay. So does that help us at all? So we now have 20. How many grays do we have left? It must be like 19. Is that right? Is it 19? Yeah, I think it's about 19. 24. Oh, is it more? Oh, it's 24. Okay, that's 18 plus 6 is 24. Oh, it is 24. Okay, but we can't do 24. We're messed up again. We can't do this because if we do 24, then these 2 pink ones are going to be turned into non-pink. So we're messed up again. We are stuck. Okay, so that we got close, but we totally messed up. Okay, so a bit sad for us right now. A bit sad. There's only 6 green, not 7. Oh yeah, thank you. That's what was wrong. I knew there was something funny there. Okay, so you have to choose another green, guys. What green do you want to choose? 19? Okay, 19 it is. Done. So now how many do we have left? We only have 23 left now, right? That makes sense. Yeah. So we want to be able to make this one blue. We want to do that, but we can't because of these 17 and 18 being pink. That's the problem. Okay. So it's a failure. Maybe we can only do 2 colors here. Maybe it's not possible to do 3 colors. Certainly looks impossible to do 4. That, I think for sure we can say that that's impossible. Switch the 19 to the 3. Yeah, we could do that. Does that help us? Switch the 19 to the 3. So this was an idea by McLaughlin. But does that help? I mean, I don't think that that's helping the 23. 25 would, but we don't have 25. That's the problem. We don't have 25. We only have 23 gray blocks. So right now, the only place that we could build another blotch is on the 23, starting on the 23. Switch the 17. So this is Freeling suggests switching the 17 and 18 to the 8 and 10. Okay, so let's move that, getting rid of that and switching that to the 10 and to the 8. I don't understand. To the 8 and 10. Okay, well, I understand that part of it, but not the 10, because the 10, not the 8, because the 8 is way over here. Okay. Oh, you want the 4. So sure, we could do that. Oh, this looks more positive now. Yeah, this looks way more positive, because now we can kind of go like this. I guess we can color these ones differently because they're right next to the 23 blotch. So we'll color those like that. And yeah, you guys have got a solution with 3 colors. Yeah. I'm pretty sure that 4 is impossible. It looked like we were stretching us to the limit to be able to manage to get 3 squished in there. Yeah, 3 colors. So, of course, most artists don't work on such a small canvas. Most artists work on a larger canvas, maybe a canvas like this. So I don't know how many colors we can squish in here, but why don't we try? Yeah. Yeah, I agree. Can you imagine being Michelangelo or Picasso or any of the great painters, and this is your fresh new canvas? Okay. Yeah. So absolutely, Janowski, this is Janowski's first idea. Of course, Janowski comes in here and says, okay, I'm going to go like this. I'm going to go like this. And I'm going to go like this. As here. And Janowski starting off with a blotch on 100. But Janowski, the all yellow person. So Janowski, you're all yellow, and congratulations. That is a solution. But most of us want to use more than one color whenever we paint. So let's try to do more than one. Yeah, Janowski won. Okay, let's say Janowski won, and now we're going to try to, the rest of us are going to try to win with more than one color. Okay, 6. Yeah, okay, 6. So again, we have this idea of using 6. We're going to use 6. All of those around the 6 have to be active. So we're going to make those like that. There we go. There's 6. Happy? Somebody is saying 30. You wanted to use 30? Try 14. Well, we can't use 14 now because we can't go on 5 or 15, because then these have to be the color of green. Yeah, so that's not going to work. Ford wants to try 30. So we can definitely try 30. And there's 30. We have to surround those. So that's the 30 surrounded. And then we want to, like, I'm guessing we want to do all of, I don't know. Anyway, there's a lot that we can add on here. Okay, let's see how many we can add. We're at 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Oh, we can just fill in all of these. There, that's easy. So that's just temporary. I'm not saying that that's going to be the solution, but it's just faster for me to do something with 30 than just saying, okay, let's just, you guys can just name it. So we can change this around. So we've got 6 and 30. 20. We've got, oh no, we can't do 20 now because it's part of the 30 domain. It's like right next to the 30. 52. You want to do 52? Okay. Stinson says 52. And we'll make that, no, let's make it nice blue. There we go. Yeah. And there we go. So 52, we have to get, let's see how many we're going to be highlighting here. We're going to be highlighting all of these. That's going to be 50. That's 50, 51, 52. So that's 52. I'm not saying that this is final, guys. This is just, oops. Okay, let's go like this. So I'm not saying that this is final. This is just the kind of thing that we're going to be looking at. And I guess we've got 12 left here. So let's say instead of taking this 12, we could take something else. What about this? Does this make sense, guys? So we could do red here. Okay, and this here. So we could go like this, and then these ones all have to be the blue. Is this kind of what you were thinking? So that's for 52. I think that's right, 52. So we've got 4 in there. Yeah, 1 doesn't work. In fact, I don't think 1 works for any size of canvas because you always need to surround it. So it's always going to be 4 squares. Yeah. Okay. So is that the best we can do? 52? Yeah. Yeah, 52 works. But just a wild guess. Now, I'm not sure if you can get better than 52. Yeah. So, but that's the 52 solution, Stinson. A wild glass. Yeah, it is beautiful. That's, whenever I'm making math puzzles, I'm really motivated by beauty. Math should be beautiful. It is beautiful, but so often math puzzles end up not looking beautiful. They should look beautiful. So exactly, I totally agree. Can we make 52 smaller? Yeah, because we don't want to have just 4 colors in our giant canvas. We would like to have more than 4 colors. So just a random guess can work, but did it turn out to have as many colors as we need? 52 is pretty big, and it turns out that that meant that we could only fit 1 other color in. Okay, so go ahead. You would like me to go back. I can go back. Instead of choosing 52, I can choose 42, if you would like that. You'd like me to choose 10. Okay. 6 and 10 and 12. Okay, let's try that. 6, 10, and 12. So that does look a nice small set. Now, I shouldn't color them all red. Wait a second, that's wrong. Okay, I'll color this one blue. I'll color it red, this one red, and I'll color this one like that. Okay, so all around these ones, I'll just do this for temporary. We'll do that like this. So that's the 12. We can change it if you guys don't like that. This here is the red. And this here, I don't know what you want to do for the blue, but let's, for as a temporary measure, let's go like this. There. Okay. So this is just temporary. 4. So the idea, Rader's idea of 4, but that 4 would have to be surrounded, and that would mean that it would look more like the 6, and the 6 has 6. So no, it doesn't work. The 4 won't work. Now, what do we have left? We've done 10 and 6 and 12. And what do we have left? So that would be 22 plus 6. That would be 28. So 100 minus 28, is that like 72? So of course we could go up here and immediately just grab 72, but then we're again stuck with just 4 colors. So is there a way to get less? So here is an idea, because this 36, this 36 looks tempting, right? It's low down. So I agree. Let's try the 36 Raider. Let's try that, see if it works. So we'll go for green in there. It has to be surrounded. Okay. And let's go with that. Whew. So how much do we have left here? 72 minus 36. Isn't that 36? Like, I think we're at 36. But we have to add a lot more, obviously, but I'm not sure what we're going to do then. Not obvious. So this is hard to get to 4, to get beyond 4. So we've got to 4 colors with that random guess of the 52. We got to 4 colors. Can we get to 5, or is 4 as good as we are going to get? So that's where I'm going to leave you guys. I don't know. Do you want to take a guess? How many people? Yeah, I could ask the question here. So how many people think that 4 is as good as we can get? Okay. Okay, let me see this. Okay. There we go. Option. Oh no, that's good. Send. Okay. So that's going to be my question. 4 or 5. I want to see what you guys say. Did you guys get that question? Oh, maybe it didn't send. Don't think it sent. Okay. So Whitaker says 4 or 5, I guess. Park says that he thinks Park says 5. Willis 4 or 3. No, we know we can get the 4. We just did it. Moore says 5. Willis says 4 or 3. Oh, Willis says 43. Right. Well, of course, if we try 76 isn't going to work, because instead of 36. And if we try 43 here, I understand now. So if we try 43 like this, okay, so this all looks good, except we have a problem. What's the problem? There we go. Let's just go like this. So we have to make this green. We have to add until we get to 36 greens, right? So right now we're at 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. Okay, there we go. So we could do something like that. Okay. The problem is there's not enough now to do 43. So we've got 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36. So we do not have enough. We've got 36, not 43. So it's a total fail. So this was a total fail. Yeah, so it's not obvious if you can get to 5. Not obvious at all. It's easy to get to 4. Like you just saw, we could just randomly choose a number and we can probably figure out a way to make that number work. But to get to 5 different blotches, that's not obvious. Janowski says that we can do it. I believe in you, Janowski. You have shown us in the past that you can take a yellow paintbrush and paint an entire canvas and call yourself successful. We believe in you. Okay, so yeah, so that I'm going to leave you guys with this puzzle. We'll return here, but that's what you guys have to do. Figure out, can you do it with 5? We're going to go back for the last few minutes and just I want to remind you of this puzzle that we dealt with a couple of weeks ago. This was the puzzle with the Indonesian puppets and the puppet tyrant. And you remember that there were some rules. The first rule is that your pillows, they had to decrease. Okay, you couldn't have the pillows for example, like this, going all over the place. So no, you have to have them strictly decreasing. The second rule was that whenever you are comparing these pillows, which one of these throne rooms is victorious? To compare, you look at the first row of pillows. There's 5 over here, and over here there's 6. So who wins? The 6 wins. In the second column, there's 4 over here, and there's 5 over here. Who wins? Obviously the 5. And for the third column, there's 4 over here and 3 over here. So again, the person on the right is winning for number 1, number 2, number 3, and the person on the left is winning for number 4 and number 5. It's 2 versus 0 and 5 versus 0. Okay, so that's a 3 versus 2 victory for the person on the right. Okay, so one response that I had was not dealing with 15 pillows, but just dealing with these little mini pillows. This is like 6 pillows. And what this person found, this was Lee, found this, that for these ones, there are only 4 different thrones. So there's the straight up and down throne, there's the staircase throne, and there's these 2 like L-shaped thrones. So there's only 4 different thrones, and these 2 thrones are beaten by this throne here. So the staircase throne wins all the time, and this throne can't be beaten. Neither of these thrones can be beaten. Anyway, I just wanted to share that result from Lee. If you want to go back and look at that puzzle, feel free. Anyway, the main thrust today is to try to figure out what is it possible to get to 5 here without having an error, like the number 43 was an error. Is it possible to get to 5? So good luck, and I'm thinking of you guys through this irritating time and sad time for the world. So you guys take care, and I will see you on Wednesday. Bye-bye.